Namaste, I am Sujati Kare from class 10 JSS Srimanateshwar Central School, Dharwad.
Hello everyone, this is Karthik Araj, studying in class 10 at Jesus Sri Manjunatheshwar Central School, Dharwad.
Myself Aradhya Abhikar, studying 10th in JSS Sri Manjunatheshwar Central School, Dharwad. Power source. An ornithopter needs a power source to move their wings. This can be done in a variety of ways, including batteries, gasoline, engines, or even the human power. Control surface. Ornithopter need a control surface to steer and maneuver in the air. This can include ailerons, elevators, or ruders. Fuselage. The fuselage of an ornithopter is the main body of an aircraft. It is the home to the power source, control system, and other essential components. Landing gear. Ornithopter needs a way to land safely on the ground. This can include wheels, slides, or any other landing gears. Body coordinates with every part and organ to live. Similarly, the bird has to have various parts of the body to coordinate and fly. Let's come to the parts of bird, starting with wings. An ornithopter's wings are designed to flap up and down in a way that allows one to soar like a bird's wing. They are usually made of lightweight materials such as balsa wood, foam, or a carbon fiber. Flapping mechanism. The mechanism of the ornithopter's bird is that of the raising and lowering the wings. This can be. Let's come to a very important point, which helps the birds to fly, which is components of birds. We have used many different electronic components, starting with Arduino Uno, an RF24L01 branch receiver, an RF24L01 adapter, breadboard, an RF24L01 IRES, normal wires, PVC foam sheet, small hinges, small screws, Wi-Fi camera, joystick, rechargeable battery, servo motor, brushless motor gears, Arduino Nano dumping cables, PCB sheet, motor gun, and glue stick. Let's come to the important part, which is very important for the birds to fly, which is the components of bird. We use many electronic components, starting with Arduino Uno, an RF24L01 transceiver, an RF24L01 adapter, breadboard, an RF24L01 IRES. Myself Aradhya Abhikar, studying 10th in JSS Sri Manjunatheshwar Central School. I want to give an overview of a very valuable concept which has much to do with physics and can even be done to fly a robotic bird, which is center of gravity. The center of gravity is a point in an object where the weight of the object is evenly distributed in all the directions. It is also known as center of mass, as it is the point where an object would balance if it is suspended from that point. Taking this as a reference, we have considered a point at the center of the bird which will act as a center of gravity or mass. The concept of gravity helps us to predict how a material will behave when subjected to external force such as gravity or acceleration. For example, a stable object will have its center of gravity in its support base. It is the center of gravity is outside the support base, the object will be unstable and likely to tilt. Hello everyone, myself Aradhya Abhikar, studying 10th in JSS Sri Manjunatheshwar Central School. Today I am going to.
The sheet which we have used for this ornithopter is PVC foam sheet, which has air holes and reduces the mass of the bird. We have used honeycomb structure for this bird as it reduces the weight and gives stability and provides even more strength to the bird. For flying of the bird, we have used the most important motor, which is brushless motor, which gives a RPM of 70,000 per second, which is quite really speed. As you can see in this image, the length C determines the hypotenuse of the triangle where the flapping of wings take place. The angle at the motor is perpendicular to the set of gears kept at the center of the gravity of the bird. The length y from the center is equal to the equal at the gearbox to the motor at length c and length am, which is equal to the half of length height h. The length l is equal to the height h. The angle beta A is equal to the theta at the motor. As you can see in this image, the flapping of the wings is directly proportional to the movement of the gears kept at the bird. The hinge in the middle allows frictionless movement of the birds. There are three sets of gears used in this bird. The movement of wings in x-axis is 60 degrees above the line of incidence and 60 degrees below the line of incidence, which is positive and negative. The area which experiences most of the air pressure is known as rocker. Cut, 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 cut.
Now last but not the least, which is also an important topic, wing shape and size. Different types of birds have different wing shapes and size. For example, some birds need to fly for long distances like that of the Arctic hare, and so they have narrow and pointed wings that allows them to soar and glide for a longer period. While there are some birds like hummingbirds which need to move quickly and so have short and rounded wings that helps them to move quickly and change the direction. So now let's come to one more another topic, which is like birds use a different flight paths to reach their goals. For example, some birds keep moving their keep flapping their wings constantly to stay aloft, like that of the honeybee and the housefly. While others, like the eagle, soar and hover to glide to conserve energy. Some birds even use thermal or pockets of hot air to fly without flapping their wings at all. So now, let's come to aerodynamics, which is a really very important concept. First, we'll study birds' anatomy. Birds have a unique anatomy that allows them to fly. Their wings are made up of feathers, which are arranged in such a specific manner that allows them to create lift and reduce drag. Also, their bones are made hollow, which makes them feel lighter and lift their body easily off the ground. Second, we'll see lift and drag. When a bird flaps its wings, it creates two forces, lift and drag. The shape of their wings are combined with the flapping of their wings, which helps them create an upward force called as lift that helps them stay in the air. And also at the same time, they also need to overcome a force called as drag, which is created by the air resistance.